Okay, this lecture is over Chapter 7 of your textbook, which is titled Preparing for Attacks. Some of the things we'll talk about in this chapter in a little detail in this video are net flows, logging, in particular syslog and Windows event logs, firewall logs, router and switch logs, and we'll talk about log servers and monitors. And then we will talk about antivirus, and then incident response preparation, and we will talk about what Google Rapid Response is, some commercial offerings related to the topics in this chapter, and then we'll talk about security information and event management. So the first thing on that list was net flows. And basically what a net flow is it is a collection or sequence of packets that share common characteristics such as the source and destination IP and the port number were the same, packets traveling between those two endpoints within a specific time interval, usually a few seconds. It won't be, for hours or days or anything like that. The concept of NetFlow was originally come up or developed by Cisco, but these days many people use NetFlows or variations of NetFlows. NetFlows are sent out via UDP packets that have no payload, but they have information about the various net flows. And typically, these are the ports that would be used to send out the net flow information. And then you have a collector that looks for those net flows and records them. And what I have here is a sample of a few net flows. So each one of these, if you look at source and destination IPs, there are some duplicates, for example, the first two. But notice that the source port is different. So that's actually two different conversations. The first one looks like it's an HTTPS request. The second is an HTTP request. It then tells you how many packets were in the flow and how many bytes total of information was sent between those or related to those flows. So that's what a net flow is. The next topic in the chapter is logging, and logging is recording events, activities, state changes, etc. for the purpose of reviewing, analyzing, and or auditing them later. There are several different types of logging that your textbook talks about, or software packages or systems for logging. The first it talks about is syslog. And what we have here is a way to specify messages that are to be recorded. Syslog originally came out in the early 80s, and it was part of BSD Unix. BSD stands for Berkeley Software Distribution. So in the early days, Unix was created and distributed by AT&T. In the early 80s, Berkeley, that is University of California, Berkeley, started taking the source code that AT&T was giving away and started to make modifications to it to make it better or have more functionality. And then they would in turn distribute what they were calling BSD Unix through the Berkeley Software Distribution, the BSD people. And it was originally created by Eric Allman. Eric Allman also wrote SendMail, which is the first mail delivery systems that was used in Unix. Now, the way syslog works is you have messages. Those messages have a priority, a timestamp, a host name, a tag, and a message. And the way the priority is calculated is using the formula, what is the number of the facility? So the facility will be like mail or backups or something like that. You multiply that by 8, and then you add the severity to it. Severity are things like informative, warning, error, critical, etc. So an example message would look like this. In the brackets, and there literally are brackets there is a 34. So that's the encoding of the facility and severity. And there's a date time stamp as to when the error was logged. It came from router 1. It was related to the secure shell daemon, which at the time was process ID 1234. And the message that was logged was there was a failed login attempt for admin. So it will send those. Now, the different facilities and priorities are in the syslog.conf file, or the syslog config file. And here's an example of what it might look like. So for any kernel message, regardless of the severity, that's what the star is, we're just going to log that to var log kernel.log. Anything related to mail, we're going to log it to var log mail.log. The next line, star.emergency, I don't care what facility it's coming from, but if the severity is emergency, then it's going to send it to star. And as the comment right above says, that star means send it to everybody that is currently logged into the system. And then you can also send these to other syslog servers. So anything on the local machine, local.0, regardless of the severity, send it to the syslog-d server that is running on 192.168.1.50. So that's some information about syslog and how it works. Another popular thing in the Windows world is the Windows event log. And basically that is a built-in log that records system security and application events and uses them, or can be used later, for troubleshooting, monitoring, and investigating security incidences. Now, the event log came about in 1993 when Windows NT was released. Potentially before some of the people in the class were born. But anyway, you had Windows 95 and Windows 98, which were very, very popular releases of Windows. But then they came out with NT, which stands for New Technology. So it was a total rewrite of Windows with kind of server concepts built into it, is the best way I would describe it. If you want to get to the event logs, the easiest way to do that, there's probably 4 or 5 ways at least. But if you hit the Windows key, hold down the Windows key and press R, that brings up the Run dialog box. And then in there, the snap-in name is event vwr.msc. So that's something from the Microsoft Services Console, but that you can run it directly without going into the console. And that's the way you do it. Now, when you do that, you get something that looks like this. And there was a whole lot of information, and there was no easy way for me to get everything on the screen. But in the left column, you have the different kinds of logs, and I expanded the Windows logs. And you'll notice there's the security log, the application log, the system log. It can also have forwarded events, which were events that were generated on other machines that were sent to the machine that you're logged into for centralized logging. And the window on the right, you have the different log entries. So in syslog, we had severities, and there's like 16 of them. Well, in Windows, we have warning, informational, and error are the three most common. And I clicked on one of them, and it's the one that's highlighted. Notice it has a date and time there. I grabbed it the day I made this presentation. And then down at the bottom is the actual log message, which there's a scroll bar, and it can be quite long sometimes with lots of information. But this was an app crash. So you had some application that was running that for whatever reason crashed. In the details, you will probably have more information about exactly why it crashed. Another type of logs that we have when we're dealing with cyber security incidences would be firewall logs. And you should already know what a firewall is. The firewall logs are log keeping track of what the firewall did. One thing to point out, this should be something hopefully you've learned, but if you have not, there are two types of firewall. There are software firewalls and hardware firewalls. Software firewalls, as the name implies, is firewalls that are running that are software. They're not physical hardware. So things like your Windows firewall that you have on your machine, that is a software firewall. A hardware firewall is an actual device that does the processing and deciding what to do based on firewall rules. Now, the advantage of having a physical firewall is they are much faster and can handle a lot more transactions. I should have looked at our UK, one of our Palo Altos, before I made this lecture, but it can do millions of packets per second. Looking at them, determining whether or not to permit the traffic. Now, the disadvantage of a hardware firewall is the cost. Now, on a firewall log, here's what it might look like. At this date and time, we allowed a packet. Here's the source IP and source port. It was going to the destination IP on the destination port 443, and the rule that allowed that was web access. So web access is a rule that probably says anything that's going to port 443 or port 80, let it go through. The second one, we have a deny. There was a packet that was going to port 22 on the destination IP, which is SSH, and for some reason it was blocked. Now, it may be that, for example, a lot of our machines on campus, we block SSH from off campus. However, if you go through the VPN, then you're considered on campus and SSH would be allowed. Or it could be that somebody is hacking us from the IP 203.0.113.45, and we just put a block in to say for that particular IP, don't allow them to SSH. So we would have to go look at the rule block _SSH to determine exactly why that might have been blocked. And in the next one, there's an allow for UDP to port 53. And if you don't know this, if you need a DNS server and you don't know exactly what you're supposed to put there for your organization, you can always put 8.8.8.8, which is Google's DNS server. Now, we can have router and switch logs, which are a recording of events and activities that network devices generate, primarily switches and routers. If we look at an example switch log, it might look like this. These would be things that would be logged to the console. If you've had CIT 161 or 167 and configured a switch, you would have seen things like this, like this link on switch 1, gig 1/0/0 went down, and then 3 seconds later it came back up. So either somebody shut it down and brought it back up really quickly, somebody unplugged the cable, plugged it back in, there was some network glitch or disturbance that cleared pretty quickly. So that's an example of switch logs. Now I have a switch example of a router log, and it will look like this. Again, we have interfaces that are changing states. We have a OSPF, which is a routing protocol. Open shortest path first is what that stands for. Students typically learn about that in CIT 167, Cisco 2, but somebody shut the routing protocol down. And in the next one, somebody tried to log in from the given source IP into the admin account via the console, and that failed, presumably because they gave the wrong password. Related to logging, we have log servers and monitors. A log server, I kind of alluded to this when we were talking about syslog, is a centralized place to consolidate log messages. And there are several things that allow you to do this. In the late 90s, Nagios came out for Unix and Linux and was very, very popular. These days, Splunk is very common. There's something called SolarWinds Log Analyzer, and then Microsoft has Microsoft Sentinel, which is their log server and monitor for Azure, their cloud. AWS, Amazon Web Services, they have something called CloudWatch, which we will probably look at some point closer to the end of the semester using our AWS Educate machines. And then GCP, which is Google Cloud Platform, has something called Google Cloud Log for logging things that are happening in GCP. Now, switching from logging, we're switching to the next topic in the book, which is antivirus. And again, this is something you should be familiar with either personally or from courses. But antivirus is software that is designed to detect, prevent, and potentially remove malware. Some common examples of this are Norton antivirus. Norton is one of the first antiviruses. I think it probably came out in the 1980s. Also been around for a long time, McAfee antivirus. More recently, Microsoft came out with Microsoft Defender for Windows machines, and I want to think it actually runs on other machines as well. I think at one point I had Microsoft Defender on my Mac. There's something called Malwarebytes, which a lot of people like. And then there's many other antivirus softwares that you can get. The book then talks about incident response preparation, which is being ready to effectively handle incidences before they occur. So what that means is have a plan in place and identify what tools you're going to use, what people need to be involved, and what procedures, and which would include documentation, are you going to use when a cyber incident occurs. So having all of that thought out and dealt with in advance of a breach or a cyber incident so that you can immediately get on trying to figure out what happened and how to mitigate it. There are some examples. Google has something called GRR. That's software that allows you to access systems during a cyber incident, so that if they've compromised or made the machine unusable, I hate using the term backdoor, but it's a backdoor to get into the machine so that you can do what you need to do. There's another product called Carbon Black, which is similar in functionality to Google Rapid Response. The book then talks about security info management, which often is abbreviated SIEM. And this is an intelligent platform that merges multiple sources and types of logs together, along with event data, and it also includes alerting. So if it figures out or suspects something is going wrong, it will alert individuals. Some examples of this are Splunk Enterprise Security. IBM makes something called QRadar, and we've already mentioned it once, but Microsoft Sentinel would fall under this category as well. So that finishes up the lecture on Chapter 7.